Alright guys, let's do some reviewing of the charting of constants and how that relates to the proportional relationships that Mrs. Donahue wants us to review. She uses the formula y equals kx. So where k is a rate, let's see how that might relate to the constant amount of water that an elephant drinks. So let's say that we have an elephant named Sam. The ears for our elephant and a trunk. And this elephant likes to drink water from a big tank that we have at our zoo. And the tank holds 28 gallons of water, and our elephant drinks 4 gallons of water per day. So let's see if we can figure out how often we have to refill our tank in order to make sure that Sam is never thirsty. So if we have our y-axis, where y is the number of gallons of water that Sam has drank, and x is our x-axis is the number of days over which Sam has drank those, then let's see if we can figure out how often we need to refill the tank. So Sam is going to start out with having drank 0. Let's say that we have a full tank, and so Sam has consumed 0 amount of the water, then y is going to be 0. So we're going to start out with a y-intercept of 0, and we haven't had any time for him to drink his water, so x is also 0. Now if k is the rate at which Sam consumes water is 4 gallons per day, then after 1 day, right, because our rise over run is 4 gallons over 1 day. So let's see, and it tops out at 28. So half of that would be 14. Seven. I'm sort of trying to draw this to scale, but we're just going to do it roughly. So 1, 2, 3, 4. So after 1 day, we're up to 4 is our y value, and 1 is our x value in days. So when we're charting this, we can just sort of draw a line up to 28, and we know that we have to, or that's roughly what the slope of that line is going to look like. And we can solve for it algebraically. We can say y equals kx. So where k is 4, and we want x to equal, or we want y to equal 28, and we want to know the number of days, then we have an algebraic expression that we can solve. So we have 4x, so the coefficient of x is 4, and to get rid of the 4, we can divide this side by x. This cancels out. You just get 4 going into 4 one time. 1 times x is x. And anything that you do to this side of the equation, you have to do to this side. So we get x equals 28 divided by 4 is 7. So x is equal to 7. So after 7 days, we're going to have to refill the tank for sand. But we don't have to, we don't necessarily have to solve it algebraically, because we can also continue to chart. So we're at 4 here, up 4 over 1, and then, let's see, 1, 2, 3, 4, 5, 6. So up 4 over 1, up 4 over 1, 4 over 1, up 4 over 1, up 4 over 1, up 4 over 1, until we're at, finally, 28 and 7. So hopefully that gives you a reminder of that in our math enrichment class we've gone over y equals mx plus b, the slope-intercept form of a line. Here the b is 0, which is implied in Mrs. Donahue's y equals kx, which k is an interchangeable. K is a constant, m means measure of a line. When you're charting a constant, the measure of the line will be also constant. So y, in this case, we could say 28 equals 4x plus 0. And there we've solved our equation, and we know that it takes 7 days before the tank gets empty and we have to refill it for sand.